Good morning. I am Neela Unisha from the Department of AIML in Sasi College of Engineering and Technology. Today I am going to take about the subject of design and analysis of algorithm. The topic I am going to take is 0 by 1 knapsack using least cost branch and bound. So what is branch and bound? So branch and bound is one of the important algorithmic technique for solving the problems. So what is it is similar to the backtracking, but what is the difference between the backtracking and branch and bound? So backtracking means it's not used for solving the optimization problem, but in case of the branch and bound it will be used for the solving optimization problem. And also there is a difference between the backtracking and branch and bound. In backtracking we can go for the depth first search, that is we are using the stack, but in case of the branch and bound we are using only the queue, but is the breadth first search technique will be applied in the branch and bound. So what is branch and bound? Here is branch and bound is applicable only for the minimization of maximization optimization problem. So optimization problem can be categorized into two types. First one is maximization problem and minimization problem. Mostly most of the topic again in backtracking, dynamic programming and greedy techniques will be applied for both maximization and minimization problem, but only this branch and bound is applicable only for the minimization problem. So now I am going to deal with Today we are going to deal with 0 by 1 knapsack using least cost branch and bound problem. So using branch and bound and again in 0 by 1 knapsack we can have three strategies are used. First one is FIFO, that is first in first out branch and bound. Next last in first out branch and bound. The last one is least cost branch and bound. So what is the least cost branch and bound is it's the most intelligent one. It for selecting or exploring the next node, which this is called as this is the most important one and this is a most intelligent one. So we can go for the 0 by 1 knapsack using least cost branch and bound. So what is 0 by 1? Actually this 0 by 1 knapsack we can use for the profit. So that 0 by 1 knapsack will be applicable only for the maximization problem, but this branch and bound is applicable only for the minimization problem. So how we can convert? Here we are using 0 by 1 knapsack. Here we are using this 0 by 1 knapsack using least cost branch and bound. So how we can branch and bound will be used for the minimization problem and 0 by 1 knapsack will be used for the maximization problem. Then how can we apply both the minimization problem and maximization problem over here? So we have to first take the branch and bound, that is first solve the problem for minimization problem and then convert that minimization problem into the maximization one. For performing this task, first take the cost, that is take the profit of each and every object with negative value and find out the solution, and final solution will be converted into the positive one. That is the only task we have to convert from maximization problems to minimization problem. So to place, what is a knapsack means we have one bag or we have one container and we are going to place n object into the container, and that container contains the maximum capacity as m, and this object consists of some profit and weight. So this profit and weight, by including the objects into that is where we have to insert the object into the bag with maximum profit, so that this is called a 0 by 1 knapsack. So that is to place the object into knapsack we have to get maximum profit, that is p of I and x of I should be maximum. So what is here? P is represented as the profit and the x represented as the x will be either 1 or 0. That is here we are going to take some decisions, that is xi will be either 1 or 0. If it is 1 means the complete object will be placed into the knapsack, and if it is 0 means the object cannot be placed into the knapsack. So that we can call it as 0 by 1 knapsack. So what's the algorithm to construct the 0 by 1 knapsack? Derive the state space tree and compute lower bound and upper bound for each node in the state space tree. So what is lower bound and upper bound means? So lower bound can be represented by C cap. That is, for calculating the lower bound, we does not include any of the fractions. But for upper bound can be represented by U cap. For calculating the upper bound, fractions are allowed. So if both, we have to compute both upper bound and lower bound, and after computing the lower bound and upper bound, if the lower bound values greater than here, if lower bound value is greater than the upper bound value, you have to kill the node. Suppose if lower bound value is less than the upper bound, means we have to explore that node as a node. So the next we have to repeat the steps. This is a step 3 until all the nodes are examined. Next, finally, after all the objects can be included into the knapsack, then finally we have to find out the solution by by including the object or not including object into the knapsack. Final, trace the path from leaf to root in the backward direction to find the final solution. So for this problem, we are going to construct a state space tree for 0 by 1 knapsack using least cost branch and bound. Here we have 4 objects, n represented as the number of objects. Here we have 4 objects and m represented as the maximum capacity of the bag. So we are going to place 4 objects with maximum profit of the 4 objects. That is, either we can include object 1 or 2 or 3 and 4, but the maximum profit of the objects which will be included into the knapsack will be maximum. So each and every each and every object has some profit and weight. A profit for object 1 is 10, object 2 is 10, and object 3 is 12, and object 4 is 18, and for next we have some weights also for each and every objects. So we have to consider all these objects and by including into the knapsack or not including into the knapsack and find out the maximum profit. So we have to first find out the maximum profit for this. So this is actually a maximization problem. We have to convert this maximization problem into the minimization problem. So for that, first take the negative weight of the profit. So profit value will be taken as negative weight of each object as minus 10 for object 1, minus 10 for object 2, and minus 12 for object 3, and minus 18 for object 4. First we have to take the profit and convert each and every positive value of the profit into the negative one. Next, take the weight as it is. So foremost step is we have to convert each and every profit of the objects into the negative values. Then insert the dummy node into the priority queue. Insert the dummy node into the priority queue, and this first 0 represented as the least bound value and least bound value, and this 0 represented as the upper bound value. So left branch and right branch are at level stores the maximum value, including for left represents the values included into objects which will be included into the bag, and right represented as the objects will be not including into the bag. That is, we have to use on the left hand side we have to use x as 1, and we have to use on the right hand side as x as 0. So first take a dummy node with C cap, where C cap represented as the lower bound and U cap is represented as for each and every node we have to find out the lower bound and upper bound for each and every node, and C cap will be 0, take C cap as 0 and U cap, that is upper bound, as 0. Mark this as node 1. Next we have to consider the next node by including the object and by not including the object 1. So object 1, profit and weight. So profit of object 1 will be minus 10 minus 18 and weight will be 2, 6, 4 and 9. So first I am going to insert the object, that is place the object into the knapsack. So you have to write x, that is x represented as the object 1 will be placed into the knapsack. Suppose if we write x1 equal to 0 means not including the object into the knapsack, that is we are not going to insert the object into the knapsack. So first we are going to insert the object 1 into the knapsack, make this node as 2 and make this node as 3. For this, for each and every node we have to find out the upper bound and lower bound. So for node 2 we are going to find out the upper bound and lower bound. So lower bound can be represented as C cap. How we are going to insert the object 1. So first, maximum capacity of the bag is 15. First object weight will be 2. Now I am including the object 1. So consider x1 as 1. So we are including the object 1. Its weight is 2. The maximum capacity of the container is 15. Now 2 is placed, weight of object 1 is 2 and this will be placed and the remaining weight will be 13. Next again we can go for the next object whose weight is 6, but its the remaining capacity will be 13. So we can place the object 2 into the knapsack. So its weight will be, actually its weight will be 4 and 6. Its weight will be 4 and the remaining weight will be 9. Now we can go for object 3. Object 3 has the weight of, object 3 has the weight of 6. So the remaining weight will be, remaining capacity of the bag will be 9. So we can replace the object 3 whose weight is 6. Now the remaining capacity of this bag is 3, but while we are going for object 4, its weight will be 9, but here we have only, the remaining weight we have only 3. So out of 9 we have to allocate only 3 and we have to multiply with the maximum profit of the object 4. What is the value here will be 2. So 3 minus 3. The profit of object 4 will be minus 6. Here is minus 6. That is, here we have to multiply 3 cross minus 18 divided by 9. The answer will be minus 6. Minus 6 will be considered for the profit of object 4. So what is least cost bound, least lower bound for this one? That is, for lower bound fractions. For lower bound fractions are allowed. So we have to add all the profit of all the objects. Minus 10. So profit of object 1 is minus 10. Then profit of object 2 is minus 10 and profit of object 3 will be minus 12 and profit of object 4 will be, we have to include only, not fully included or not completely included the object 4. So we are including only fraction of the object 4. So its profit will be not 18, it will be 6. So final answer will be minus 38. So lower bound for this node is will be, lower bound for node 2 will be minus 38. Then how can we calculate upper bound for node 2? C cap already calculated, minus 38, and now we are going to find out the U cap for node 2. That is U cap represented as upper bound for node 2. How we are going to find out upper bound means for upper bound fractions are not at all allowed. So the same thing we are going to do for the maximum capacity of this knapsack will be 15. First include the object 1 profit will be minus 10, minus 10, minus 12 and minus 18. Then its weight will be 2, 4, 8 and 2, 4, 6 and 9. First include the object 1. Its weight is, maximum weight is, so its weight is 2. So the remaining capacity of the bag will be 13. Next include the object 2 and its weight will be, weight of object 2 will be 4. The remaining capacity by 13 minus 4, remaining capacity will be 9. Next include the object 3. Its capacity will be 6. The remaining capacity of the bag will be, knapsack bag will be 3. Now the object, to include the object 4, we are having only the remaining weight will be, remaining capacity of the bag will be only 3, but the object here, object 4, the weight will be 9. Then we cannot include, we cannot make any fractions for upper bound, so we have to ignore the object 4. So what will be the total profit or upper bound for this means you have to, we are including, we are ignoring the object 4. So for you have to find out only the profit for object 1, minus 10 and plus minus 10 plus minus 12. This is a profit for object 3, object 1, 2 and 3, and finally answer will be minus 32. The upper bound for node 2 will be minus 32. Next, in the same way we can find out for node 3. That is, here we are considering the object 1, that is included the object into the bag. Here on the right hand side we are not including the object 1, that is we have to consider it as x1 equal to 0. For node 1, your lower bound will be 0 and upper bound will be 0. We have calculated now for node 2, lower bound value will be minus 38 and upper bound value will be minus 32. Now we can explore for this node 3, that is we are not including the object 1. Here we are including the object 1. By including the object 1, we got the upper bound, lower bound value as minus 38 and upper bound value as minus 32. Here we are not considering the object, including the object 0, that is 1, and we have to find out both upper bound and lower bound for this node. How we are going to find out for node 3? So for node 3, again the same thing. For first to find out the lower bound, that is C cap, we are going to find out m equal to 15. Since we are not considering the object weight, profit and weight of each and every object will be, this will be minus 1, minus 10, minus 10, minus 12 and minus 18. This will be 2, 4, 6, weight will be 9. Maximum capacity of this bag will be 15. Now I am going to include, not considering here this one x1 equal to 0 means we are not considering or we are not including the object x1 into the bag, that is we are ignoring the object this. So directly we have to include the object 2. Object 2, weight of object 2 will be 4. So my maximum capacity of the bag is 15. 15 minus 4 will be answer will be 11. Next we have to include object 3. What is the weight of object 3? Object 3 is, weight of object 3 is 6 and the remaining capacity of the bag will be 11. So we have more space will be available. So we can include object 3 into the knapsack. So the remaining value capacity of the knapsack will be 5. Next, now we are going to insert the object 4 but the remaining capacity of the bag will be only 5, but weight of object 4 will be 9. We cannot include, so we have to cut it. That is, we have to make some fraction of it. That is, out of 9 we are including only 5, and we have to multiply it with the its corresponding profit. Answer will be minus 10. So this value will be minus 10, and the profit of object 2 will be minus 12, and object 2 will be minus 10. Total will be, for lower bound we have to find out C cap is equal to minus 10 plus of minus 10 plus of minus 12. So out of this will be, answer will be minus 32. So for this, the lower bound value for node 3 will be minus 32, and again we have to calculate for upper bound value. So upper bound value will be like this, U cap. So for upper bound, for calculating the upper bound, fractions are not at all allowed. So for here, first include the object, maximum capacity of the bag is 15, and include the object, not considering here this one, we are not considering the object 1. So ignore object 1 and may include the, directly you have to include object 2, its weight will be 4, and the remaining capacity of the bag will be 11. Then you have to include the object 3, its weight of object 3 will be 6. Then remaining capacity of the bag will be 5. Now the next remaining capacity of the bag will be only 5, and weight of object 4 will be 9. We cannot include, we cannot insert the object into the object 4 into the knapsack. So because here in upper bound for calculation the fractions are not allowed, so ignore the object altogether and find out the maximum profit of including the object 2 and 4. Object 2 profit will be minus 10, and object 3 profit will be minus 12. So answer will be minus 10 plus minus 12, which is answer will be minus 22. So for node 3, the minimum lower bound value will be minus 22, and the upper bound value will be minus 22. Now we have explored, considering here node 2 will be considering the object 2, object 1, and node 2 will be explored like not including the object in 1 into the knapsack. Among these two nodes, now we have find some solutions, partial solutions for node 2 and 3. From this node, which node can be explored next? So we are, for exploring the next node, we have to find out any of the lower bound value which is lesser than the another node. So the node 2 consists of, the lower bound value for node 2 will be minus 38, and lower bound value for node 3 will be minus 32. So minus 38 is less than, that is node 2 value must be less than the node 3 value. So we have to explore, we have to select any of the node which is having lowest or minimum lower bound value. So here node 2 consists of minimum lower bound value. So we have to explore, the next node will be node 2. Now I am going to insert, explore node 2 by considering the object 2 or not considering the object 2 as 0. Next, by considering object 2, and this node can be named as 4 and this node can be named as 5. Then we have to explore, again we have to find out the C cap and U cap. In this way we have to calculate all the for all the nodes. We have to calculate the upper bound and also the lower bound for each and every node. Then final part will be, after including all the objects, after including So here we are considering the object 1, its upper bound will be minus 32, and here the upper bound, lower bound value will be minus 38, not considering the object. So we cannot include it into it. So that is its lower bound value will be minus 38. It is lesser than the node 3. So we can go towards the node 2. That is node 2 will be explored next or expanded next, and find out the upper bound and lower bound for each and every node, node 4 and node 5. So among this node 4 and 5, node 4 consists of the lower bound value for node 4 will be minus 38, and the lower bound value for node 5 will be minus 38. If both node consist of the same value, means we have to consider among the upper bound values. So upper bound value will be here minus 32 and minus 22. So this one having the lowest value. So next node to be expanded will be node 4. Now node 4 can be expanded to node 6 and 7, and again we have to find out for each and node, for each and every node we have to find out the upper bound value and also lower bound value for node 6, and compare the node 6 and node 6 and node 7, the lower bound values. Here both are equal. Suppose if both are equal, means we have to explore, we have to consider about the upper bound value. Here upper bound value for node 6 will be minus 32 and node 7 will be minus 38. So this one having the lowest. Which one having the lowest one? Node 7 having the lowest or minimum upper bound value. So in order, so that we have to go towards, we have to select node 7 and explore further. Here we have included. So how we can came here, included the object 1, included object 2, and here not including the object 3. This one is x3, this one is x2, and this one is x1. And finally we have to consider the object, whether the object 4 will be included or 4 will not be included. By considering this one, we can get the solution of for 8 and we got the node 8 and 9, and the solution of our upper bound for node 8 will be minus 38, and my lower bound for node 8 will be minus 38, and for here also for node 8 upper bound value minus 20 and lower bound value will be minus 20. Among these two node, that is among these node 8 and 9, the lower bound, which one having the lowest bound, minimum lower bound value? So node 8 having the minimum lower bound value, which is 38. Here it consists of minus 20. So this one will be the solution path. So how we are going to find out the solution means, trace the root from the leaf to the root and write it in the reverse order, right, from right to left. So here 1 and 0 right here, then that is solution will be, so here from 8 to 7 we got 1, next from 7 to 4 we got 0, then 4 to 2 we got 1. This is the path we came here, right? This is the solution node. Final solution node will be here. Next will be answer. So this means we are going to insert. We have inserted the objects of object 1 is inserted into the knapsack, and object 2 is inserted into the knapsack, and finally object 3 also included into the knapsack. But we have ignored object 3 is ignored here. So what is the profit? Total profit will be, we have to use the profit of object 1, add the profit of object 1, object 2 and object 3. Actually profit of actual object 1 is minus 10 plus object 2 will be minus 10, and final answer for object 4 minus 18. So final answer will be minus 38. Since this is this minus 38 will be considered, this is a solution for minimization problem. We have to convert this minimization problem into maximization problem. So we have to negate this value, that is positive, negative value will be converted into the positive value. So total profit will be profit of this knapsack problem, 0 by 1 knapsack problem will be 38 by including the objects, object 1, object 2 and object 4. This is a solution path. for the above problem. Finally, we have given one assignment problem. So try to find out the profit for a 0/1 knapsack using least cost branch and bound for n number of objects with maximum capacity as 30, and with profit of each and every object will be for object 1 5, 8, 13, 16 and 22, and its corresponding weight will be 3, 5, 8, 11 and 15. Thank you.